Redundancy is something we don't want to hear about in relation to our jobs. However, in engineering, and I'm including IT as a branch of this, it can be highly useful. You may remember I used the term redundancy in relation to data compression. Here we use the fact that some data can be removed without impacting the quality of the information stored, thus reducing the amount of storage needed. In data center design, the idea is to add redundant components such that if some of them fail, operations can continue. We'll stick with the theme of storage to illustrate the point, but if you were to look at servers or networking, you would find redundancy there too. The basic building block of a storage system is a hard drive or perhaps an SSD. We don't need to differentiate here. There is no difference from a redundancy perspective. Let's just call it a drive. If we only have data on one drive and it fails, we have lost the data. So what we might decide to do is have a second drive and build a system which mirrors the data onto both drives. If we do this smartly, we can also build in failover, such that if either drive fails, the other one can maintain availability of the data. Drive mirroring is a valid option which is used in certain circumstances. However, it is very costly because we need twice the drive capacity to store the data safely. We'll come back to this when we talk about RAID, but for now we'll stick with mirroring. If we zoom out from the drives, we see that they must be housed in a system of some sort, which must provide connectivity to whatever application is creating the data and also provide power to the drives. This begs the question, what if the power was to fail? Or what if the connection fails? In either scenario, access to the data will fail. An application somewhere will stop working. What if this is a financial application? Where will that $1 million transaction be stored? We have found two single points of failure, the power supply and the network connection. So how can we mitigate this risk? The answer is redundancy. We designed the system to have two power supplies and two network connections, each with automated failover capability. We could expand out further and analyze all the components between the drives and the application which is creating the data. Every time we find a single point of failure, we must build in redundancy. As you can imagine, this all adds up from a cost perspective. When IT systems are designed, there is always a trade-off between cost and benefit. In the case of a banking system, the cost is probably justified. In the case of storing a PowerPoint file with some information from a recent meeting, it will be harder to justify too much cost. So the amount of redundancy we need will vary based on the application. Just a final thought on this. When I cover this topic live, I ask students if there is an obvious single point of failure within a server. What do you think? In this case, there is a single motherboard through which all data is moved and processed. This is a single point of failure. We can address this in the same way we tackled other single points of failure. However, the complexity of a motherboard makes this a special case. In fact, what we need to do is use two servers and couple them together. This is called clustering. As you'll see in later lessons on network storage, it is possible to build a more specialized system with more efficient sharing of components whilst maintaining no single point of failure.